So because some of my wires got damaged taking them off the spark plugs, I figured I'd go ahead and just remove the wires, and as I'm removing them I'm seeing damaged towers. This one's got a crack in it. Actually, this one has multiple cracks. It's in pretty rough shape, I guess. A lot of these wires pulled the little terminals off them. It's no telling how old these are. They say made in the USA, so that might be aftermarket. I noticed that the wires are solid core, but these boots have these nice little heat shields. They say 1 kilo ohm, so I guess it has resistive boots, which is kind of an old way of doing things. You know, now you just get the suppressive core wires, and then you can also use like a resistor plug. I was thinking about just putting a new set of wires on it and continuing with using the car's ignition system, or letting the computer, the micro squirt, control the coil for the distributor. But now that I need a new cap and most likely rotor, it doesn't really make much sense for me to do that. So it's putting a lot of money. I mean, the wires, I could get a discount on them and get the cheaper wires. They were still $70, and the better wires were like 80 something. I know that cap and rotor is easily over $100. I thought about using the LS coils that mount on the valve cover, like a LS1 5.3 truck, whatever. And there are some threaded bosses here I could tie on to probably. So if I go to a junkyard and find that, I may do that. It's a little bit more wiring for the ECU side, because you have to bank the, I only have 4 ignition channels, as I talked about, I think in the first video or so. So you have to tie 2 coils together, and some of those cross, or most of them cross, so you end up with kind of wires going each way. So I think what I'm going to do, so I got some of these old Volkswagen coils. I need to put a new harness on this one, but it's actually about the same footprint. Once I get 2 of them on there, just mount them right there where the distributor was. I think that'll work pretty well. I guess the only thing I don't know is if this distributor drives anything. I see it, my oil pump down there for the suspension. There's the line for it anyways. So I'm not sure if I need the distributor or not. I guess I'll find out, since I don't care about the timing of it anymore. I'll go ahead and pull it up out of there. Took the distributor cap off, and it's got cracks just everywhere on it. You can see the terminals are pretty burnt out. The button looks okay. It's a carbon button, so it has some resistance. And that's another trick you can play to reduce EMI, or electromagnetic interference. It looks like a date maybe. The terminals are pretty well shot, and there's cracks just all over this thing. This just pulls off, I guess. Made in Italy. Interesting. I don't see any cracks. Definitely some heat damage. The tip of the rotor there. I'm amazed this car wasn't misfiring. Even on rainy days or humid days, it was running pretty good besides the Excel enrichment problems. Talk about this. They put this plate on here, I would assume to shield from the arcing that's happening up in the rotor section of the distributor. And you can see there's some corrosion on the tip of this shaft. I'm not sure what this debris is, if that's probably part of those terminals. This shield, you can see it's yellowed. It has a lot of cracks in it. It's a very harsh environment inside a distributor or anything that's arcing constantly, because the arcs inside the distributor actually ionizes the air, which is mostly nitrogen, and that forms I believe nitrogen oxides, the NOx's. Those nitrogen oxides react with water or humidity that's in the air to form nitric acid. And there may be some intermittent steps in there, but basically anytime you have an arcing situation, you have nitric acid formation. So yeah, the nitric acid can cause loss of lubrication on any oiled components, since it reacts with the oil and oxidizes or polymerizes it. There's a lot of debris down in here. That's probably from the terminals off the distributor cap, if I had a guess. I'm not entirely sure. You see, this distributor has a flyweight mechanism to advance the rotor shaft. Can't say I've actually ever seen this on a electronic ignition car, but it most likely is to keep the rotor kind of advanced with the ignition timing at high speeds, so that this is phased to the spark plug terminal. As the computer changes timing, you can imagine that the spark event can happen later or earlier than this being lined up on a spark terminal. So, pretty trick distributor, pretty nice. I'm not sure if this drives that pump or not, and I may just go ahead and remove it and find out. But what I'm thinking is that I can, that's the coil wire, to get that off. I don't think I should leave that shaft in there, but kind of picturing something like this. Of course, with another one turned around and stuck there. It's like the connector gets pretty close to that bracket, but it should still fit. I can maybe rotate them a little bit. Maybe something more like that. I can just make a plate that bolts down in these three locations and then has the bolt pattern for this. I think that'll work decently. And then what I'll do is get just universal wires, say for a small block Chevy, preferably the spiral core wires, and I can just run those, cut them to length, put the boots on them, and plug them into the coils, so the actual wire routing on the engine will be very similar. Well, I began wiring on this, and it's quite the mess right now. So I know it kind of looks intimidating or bad, but I think it'll actually come out pretty good. I got a lot of the split loom conduit, and these are just extra feeds I had to add. So we have one injector bank feed, and the second bank, and then this feeds the Hall effect sensor. Decided to mount the fuse panel here, and put the main relay in here, and I'll attach it to the side. These are all the unused wires, so these actually don't go anywhere. The pink wire will actually go to the oxygen sensor, and that's pretty much it. And the red wire gets power. And those other things are CAN bus or fast idle. I think there's a flex fuel input. There's a couple extra inputs. Pretty much out of outputs. I think I have one output wire left I could use for something, which may end up being the transmission kickdown. And then there's the TAC output wire, which appears I just need to run it to that little junction next to the diagnostic port. I removed well, I didn't remove it, but I unplugged all the stuff off the EZL ignition module, and still need to remove the coil on the module, but it's kind of hard to get to the bolts of that thing. It's buried pretty good. I decided to just have the wires come through the slot here next to the existing harness, and then most of these are all capped off with a little bit of heat shrink tubing that has the adhesive in it, and just taped up there. Then I can have the split loom conduit come up here and pass through the little firewall or whatever that's called. The fuel pump relay is out, and I looked at the manuals. It says pins 7 or 8, one of those go to the fuel pump and the other one's the power. I'm actually just going to provide it power from my fuse panel, I think. I'll have to look. Maybe I'll just jump across those wires with my own relay. I'm not sure yet. The fuel pump relay is pretty interesting to me. It actually has the transmission kickdown. I guess these are actually like solid state devices or something. Pretty curious to open one up. This doesn't appear to be factory. But it has a rev limit on it, which is interesting. And looking at the manual, I guess it shuts the fuel pump off as the rev limit, which is an awful way to do it. I mean, there'd be quite a delay in shutting the power off to the fuel pump and the engine actually slowing down, because there's still going to be some fuel in the system. And also, it's not great to do that because you'll cause a lean condition, and if you're that high of RPM, chances are you probably have a lot of load on the engine, so I suppose you could have detonation. They have the ignition module right here, and it's connected to the crank sensor, and it controls the coil. I don't know why the ignition module wouldn't just also be the rev limiter, and it makes no sense at all. Maybe a German can explain it to me, but I don't get why, if you get the electronic ignition module with the timing map and everything, you wouldn't also be using that as the rev limit. But right now I'm just working on the crank sensor wiring here. Take this back apart and put some shrink tube on it. And then I'll put the mating connector on the sensor and start getting this cleaned up. It'll make more sense. Pretty much it finished. I still need to put the boots. I'm waiting for them to come in on these. The wiring's complete. It got a little messy here just because that's kind of where everything comes out of. I don't think it's too bad. For some reason it just kind of bothers me a bit. Goes back and it's got a clamp here to the valve cover, and it goes back through there. The spark plug wires ran a little different than factory. I just have them butterfly clamped off of that bracket, going through another clamp there and down to the spark plugs. That main harness comes over here. Well, some of it does. These are all the unused wires. They're just tucked away here for now. I may add some extra inputs or sensors. The main power relay is here. When this white wire here gets power, it turns on and it feeds power from the battery to this fuse box. The fuse box has the micro squirt feed and the crank sensor feed tied together, and that's just going to be like a 1 or 2 amp fuse. And we have the relay feed that feeds the fuel pump and ignition coil relay. This is only 1 amp. This is just for the coil side of the relays. And I'll explain that a bit. This is one of the fuel banks, and this is the other fuel bank. I just split it. Try to distribute the load evenly like you do in your house breaker. We have the micro squirt grounds connected here. This is the ground for the main relay. And then that's just 10 gauge wire back to the battery right here. The fuel pump relay and the ignition coils relay got their own separate fuses outside of the panel, and the reason for that is this car has 2 fuel pumps, and that's a lot of current. That's probably 20 amps of current. And then the ignition coils, they can draw a lot of power too, probably up to 20 amps. So I wanted to keep them. This is only a 30 amp relay powering this fuse panel, so I just wanted to keep them separated so they get their own feeds. And it's actually fairly nice. I know it's on top of the battery, but if you just take either the battery cable or take these nuts off, you can just set all this off to the side out of the way. So I did replace the factory terminals. And the bolts were all bent and pretty rusty, so I don't feel bad about this. I crimped and soldered these copper lugs on, and then heat shrink tube with these have all the heat shrink I use have the sealant or the hot glue inside of them, so I think that makes a pretty good connection. I'm not terribly crazy about having the relay under here, the main relay, but that's where it is. It's got some length on it. I may put it somewhere else, but the hinges fold down in this area. It's fine. I'll probably tuck it away a little better. You won't ever see it. Following the harness coming off the engine, there's the wires that come over from the fuse panel. Here we have the fuel pump relay and the ignition coil relay. There was just kind of an empty spot in between the car's factory relay, and I think these are fuses. Some of the weirdest fuses I've ever seen on this car. How I did the fuel pump relay is I pulled the connector out for the factory fuel pump relay and pulled pin 7, I think. It might have been pin 8. I forget which ones goes to the fuel pump, but I pulled that wire out and then attached it to this relay. So I'll be controlling the fuel pump with the micro squirt now, and it gets its power from over there as we talked about. I don't know if I kind of see. So this wire loom here is the one that goes through the firewall, and you can just see a couple of the power feeds that loop back up into these two relays. This is the connection, the serial connection or USB connection to a laptop. So I'll need to run that serial cable over, get it through the car's firewall somewhere, and plug that in so I can have the laptop inside the car. The only other wire I have left to hook up is this white wire, and this just needs to be fed power anytime the key is on or in the crank position, because this is what latches the main power relay over there, and it's going to turn on the micro squirt and the injector feeds and everything else. So it's just long right now. I have to find a wire in this fuse panel or somewhere that I can tie into that will provide me with the power. The EZL I still need to remove from the car. It's just sitting there. But talk about these coils a little bit. So this is going to be a wasted spark car. Micro squirt, at most you can get 4 ignition outputs. There actually is a couple other. I have the tack out and another output wire, so I'm not sure if you'd actually do more or not, but anyhow, you have to use the A LED and the W LED wires as ignition coil control pins, and you have to add a pull-up resistor to do that. You can look into that yourself. So I got the amped micro squirt, which actually just has a dip switch to enable that. But we got 8 spark plugs and only 4 ignition channels, so it has to be wasted spark. These coils have 2 inputs, 2 logic inputs from the micro squirt each, and they have 2 coils with 4 towers. These 2 are connected and these 2 are connected. Now you figure that out is you just you get an even fire. There's a few ways you can do this, but the easiest way is if you have an even fire engine, just write out your firing order, and then these are going to be your ignition channels. So you can just do A, B, C, D, A, B, C, D. And so A will be on cylinder 1 and 6. B will be 5 and 3, and so on. So whatever your firing order is on a V8, you can just do this, and it works really well. And you can think there's a firing event every 90 degrees, because you got 360 degrees here and then 720 degrees here for the complete cycle of the engine, because 2 revolutions is a cycle. So I kind of just made some diagrams here. This is the way Mercedes numbers their cylinders. This is the front of the car. Here's the coils. So off of our little diagram here, I just drew lines 1 and 6, A, 3 and 5, B, 2 and 8 is D, and 4 and 7 is C. And then here the two are ganged together, and I chose to do, you could do this however you want. The micro squirt always fires it in sequence A, B, C, D. I decided to alternate them between coil packs, mostly just to reduce the heat on these drivers, so that internally to these coils, since they're logic level coils, they have drivers, and there's going to be 2 drivers in each coil, but they're all in the same heat sink on one coil. So I wanted to alternate coils just to reduce the heat input to the coil a bit more, kind of spread it out, I think. So you could really do that arbitrarily. You know, you can make this A, you can make that D if you wanted to. All that's going to affect is which wires run where, but you can't, I mean, it's a V8, so it alternates, and it doesn't work out so that you could just have one coil pack do one side and one do the other. So they're going to cross. And so, you know, since we know which ones are shared, A is 1 and 6. So I could put 1 here, or I could put it here, and then 6 would go in the alternate hole. So as soon as my boots come in, I'll be able to connect those up. This connector here is the crank sensor. It's just the 3-wire connector I got, and tucked under here is the 5-wire connector that goes to the ignition coils, and their grounds are just on this ring, and I'm going to put that underneath that other ring where this little bolt was in the intake, and that's fine to ground them to the engine. They're not a sensor. As long as they have good ground, the ignition coil will trigger them, and it's better than running grounds inside the harness and just having the possibility of more electrical noise, or interference, I should say. I haven't hooked that up yet because I need to pull this distributor base back out. You can see it's just loose, and put the O-ring on it, or else I'm going to have a big oil leak when I start this thing. I think it came out pretty good. Like I said, I don't know, it looks a little messy to me right here. I don't think there's much way around it. I mean, I could have ran the harness underneath the intake manifold, but you know, that would make it a real pain in the butt if you ever had to fix it, or for whatever reason remove it. All things considered, it looks pretty good. I like the way the ignition wires end up running. Having these spots on the valve cover to put these wire clamps worked out pretty nice. I believe next video I'll show powering up the ECU, checking out all the sensors. Hopefully everything works, and then we'll go through setting up the project, the Tuner Studio project, in the computer, inputting all the parameters like injector flow rates and how many teeth are on that wheel, and the offset for the number 1 tooth to top dead center. And we'll slowly start going through the motions of testing the ignition coil channels and cranking the engine without running, just to verify that the timing is correct. And then we'll plug in all the fuses and see if it fires up. Thanks for watching. Let me know if you guys have any questions. Bye.